All right, ladies and gentlemen, when we begin today's lesson, we're talking about igneous intrusion. So I want to give you a great picture of what one would look like. And what do you notice about the layers? Okay, where at? Up top.
Up top, like you can see.
So right up here, so you can see the sedimentary layers.
That's
Okay. What stands out to you?
giant crack in the middle.
Giant crack in the middle. Okay. And what do you notice about that crack?
Giant.
Guys, focus, please.
Rough and they cut through the thing.
Yeah, I mean, you can definitely see where we have the two sedimentary layers over here, and again over here on the right. And then we have this strange gray black material that cuts right through the layers. That's what we call an igneous intrusion. And they're really easy to identify because basically what you're going to have is the same rock on both sides, and then all of a sudden there's just this weird rock right through the center of it. And you can see these all over town. There's a lot of people that have huge boulders that are basically just plopped out of their front yard or right along the end of their driveway. And when you're looking at it, typically what you'll see is like a gray rock with this white quartz material veining its way through the rock. And those are examples of igneous intrusions. And basically what happens with this is you have the warm magma sitting underneath the crust, and it simply goes in and just starts to melt away at the rock, and then it cools, and you get this really thick vein, what we call igneous rock. That's why we call them igneous intrusions. What we're going to do now is we're going to go across the hall to the chemistry lab, and we're going to model this process. So that should be pretty cool. So let's go ahead and have you guys move over there. All right, now, in the experiment we just did, I know it took us a while to get things going, but you kind of see that relation now between the magma welling up and eating through the soils, and then very quickly solidifying, and we get this different colored material that cuts across the layers. In this particular example, this is what we would call a dike. And it's where the... Really, Peter? I wasn't laughing! Everyone else in this corner laughed. So anyway... So we have all types of intrusions. Alright, we have sills, guys, come on, quiet down. We have sills, we have laccolith, batholith, and we have dikes. In this particular example, this is called a dike because basically it cuts up through the layers. It's going to go diagonal to the layers. A sill, on the other hand, kind of eats its way in between the layers. So you would get it parallel to these layers. So if you had it where it started to come off and start going like this across the layers, that would be a sill. But when it goes up diagonal through the layers, that's called a dike. So we look at that and we think, okay, well, how do we get these? And that's kind of what brings us back to the thing I was talking about. You can actually see these all over town. If you just know, there's actually a house right over here, right around the corner from the school that has a huge boulder in their yard. And it's a perfect example of igneous intrusions in the granite rock. And so that's basically what we have here. If we think about it, it goes right back to this question. How do minerals form? How do minerals form? Guys, that's a question I'm asking everybody. Okay, they get melted, but how do we form them?
They get cool.
And they cool from
Water.
basically cooling of the magma, right? So when we think about how our minerals form, they're formed by the cooling of magma. So we go back to this picture, and you can envision this being molten magma eating its way through the rock, and then it begins to cool. And as it cools, the crystals begin to form, and then our rocks then take over from there, and we kind of work our way back down. And that's really all an igneous intrusion is. Now we have multiple types of igneous intrusions, and all of them collectively are called Plutons. And here are some common examples of Plutons. Notice in this particular location, you have this flat desert plain, and also you have this very thin razor-like rocks that just pop up out of the floor. That's an example of a Pluton. In this example right here, again, you have it cutting through the layers. You can kind of see that the layers be going like this. All of a sudden, you have this igneous rock that's popping up through. Now, one thing that's really important for you to remember is that these igneous rocks don't jump up like, don't think like that as liquid magma that's just throwing itself up in the air. What's happened is the igneous rocks tend to be more weather resistant than sedimentary rocks. So all the sedimentary rock around these Plutons has already been eroded and washed away, and so then these igneous rocks are left over as these outcrops.
Nice.
And here's a picture of basically somewhere in, I think, Colorado. And we have lots of these igneous intrusions popping up through the floor. Again, notice here we have the dike that's cutting up through our layers. Same thing over here. You have your sedimentary layers here, and then all of a sudden right down through here, you have the igneous intrusion. Now, one of the cool things that's going to be neat, I'm going to show you guys real examples of these, are things called stocks. And all a stock is literally a leftover remnant of a volcano. So think about a huge volcano, and then its neck, or the pipe that feeds out the lava, ends up solidifying. The majority of the volcano gets eroded away, and you're left with this super hard, weather-resistant material in the shape of this really tall spire. And that's basically what a stock is. And we have several examples of those. How many of you guys have seen Devil's Tower? Or have they seen pictures of it? Okay. I think it's in Wyoming. I'm not positive. It's either Wyoming or I'm almost positive it's Wyoming. We'll see a picture of that as well. Okay, so those are all examples of Plutons.